In this video lecture, I want to show you a few ways to solve problems associated with random variables which have normal distributions. I was speaking about normal distributions in two last lectures, and here I will just remind you what is this about. So X has normal distribution with mean value mu and variance sigma squared. What does it mean? It means that this random variable x capital has probability density function given by this formula: 1 over sigma times square root of 2 pi times exponent, and exponent to the power of minus half x minus mu over sigma squared, where x can have any real value. What does it mean? So plot of this function f of x has the following shape. So this is x-axis, this is our function, probability density function. So it has this kind of shape. Maximum has coordinate mu. Spread of this plot proportional to sigma. And integral of f of x dx from minus infinity to plus infinity is 1. So this integral gives probability that random variable x capital has any possible value. All problems associated with random variable x having normal distribution somehow transferred into problem for random variable, we will use notation z capital, which has so-called standard normal distribution. Standard normal distribution means that expected value is 0 and variance is 1. So then plot for z will have maximum at 0, this, and spread somehow unified. Spread is defined by variance equal to 1. Link between random variable x and random variable z is given by the following formula: z is equal to x minus mu divided by sigma. And this, I have illustrated this on the last lecture. Now we can get to our first problem and try to solve it. So in this example, the heights of ML students are normally distributed with mean value which equals to 169 centimeters and standard deviation 9 centimeters. So in this problem, we're supposed to find the probability that a randomly chosen female student is over 187 centimeters tall. So what is given? So we have random variable x representing height of female student, and it has normal distribution. It's given here. So mean value is 169, and variance is square root of standard deviation is 9 squared. So we convert immediately this problem to problem represented, or the problem reformulated in terms of z-score. So z is x minus mu divided by sigma, or x minus 169 divided by 9. Now, probability that x, so it's what we're supposed to find the probability that randomly chosen female student is over 187 centimeters tall. Then probability that x is more than 187 is equal to probability that x minus mu is more than 187 minus mu, and this equals to probability that x minus mu divided by sigma is more than 187 minus mu divided by sigma, and this is z. So this means that we have it equals to probability that z is more than 187 minus mu is 169 and sigma is 9. So this equals to probability that z is more than 187, so it's 18 over 9, it's 2. And now we're supposed to find this probability that z is more than 2. To find out this probability, we will need to use so-called normal table. So a piece of this normal table is shown on the next slide. It's just a small fraction of this. What we have here, this curve is probability density function for random variable z which has standard normal distribution. So what is tabulated here? Tabulated here is integral of f of z dz so here's this notation x from minus infinity to x. So this integral is tabulated, so we can't integrate it analytically, but we can find it numerically, and these numeric values are given here. Now, our problem was, as we remember, our problem reduced to this, to probability that z is more than 2. Probability that z is more than 2, we know that integral from minus infinity to plus infinity of probability density function is 1. Therefore, this should be equal to 1 minus probability that z is less than 2. And this probability can be found already in this table for normal distribution. So what we have? So this, it's presented in terms of x and phi of x. I will put it like this. This is 1 minus phi of 2, and phi of 2 is given in the table. So 2 is this value of x, and corresponding value of phi is this. So this phi of 2 is 1 minus 0.9772, which is 0.0228. So this is what we got. We got probability that random variable z having standard normal distribution more than 2, and we know that it equals to probability that our random variable x is more than 187 centimeters. So this is our solution. Let us consider the next problem. Packets of breakfast cereal nominally contain 500 grams. However, actual contents vary approximately normally. If average contents are 580 grams and the standard deviation is 5 grams, what is the probability of an underweight packet? So what we have here? We have random variable x representing weight of packets of cereal. It has normal distribution, so we'll say it has normal distribution. Also in the conditions it says approximately normal. Normal distribution with mean value 508 and variance which is square of standard deviation, is 5 squared. So we transfer the problem to problem in terms of random variable z, which has standard normal distribution and link between, or relationship between x and z is given by this formula. Z is x minus mu over sigma, which is x minus 508 divided by 5. Now, our problem is to find probability that x is less than 500. So this is what it means. The probability of an underweight packet. So this equals to probability that z is less than 500 minus 508 divided by 5, or probability that z is less than minus 1.6. And now we should get back to a table for normal distribution. So we get back to previous slide. What we have here. So table is given, these tabulated values are given only for positive values of x, while in our problem we got problem in terms of negative value. But since this function, probability density function for random variable z which has standard normal distribution is symmetric, then we can say, maybe I can put it here, probability that z is less than, say, minus x equals to probability that z is more than x, because of symmetry. And this symmetry we can use, this observation we can use to solve problem here. So probability that z is less than minus 1.6 equals to probability that z is more than 1.6. And this way we get back to problem which we had before in our first example. This equals to 1 minus probability that z is less than 1.6. And this value is already given in table for standard deviation. Let's look at it. So z, so value 1.6 and phi capital for 1.6, or probability that z is less than 1.6 is 0.9452. This one. So this equals to 1 minus value for 1.6 from the table for standard normal distribution. This is 1 minus 0.9452. It's what we found in the table, and this equals to 0.0548. Okay, let's go to the next problem. The diameter x of a steel bearing is approximately normally distributed with mean value 3.76 centimeters and standard deviation 0.02 centimeters. Acceptable tolerance, the diameter should lie in the range 3.73 centimeters to 3.79 centimeters. What is the probability that a randomly selected bearing will be okay? This means the diameter of randomly selected bearing will be in this range between 3.73 and 3.79. So what we have? We have random variable x, which has normal distribution with mean value 3.76 and variance 0.02 squared. We get to random variable z, which has normal distribution and which is related to random variable x by this formula: x minus 3.76 divided by 0.02. Then what we want to find? We want to find the probability that value of random variable x lies in the range 3.73 and 3.79. And this probability will be equal to probability in terms of z. It should be between 3.73 minus 3.70. Let me 3.73 minus 3.76 divided by 0.02 less than 0, less than z, less than 3.79 minus 3.76 divided by 0.02. Okay, and this equals to probability that z is between minus 1.5 and 1.5. And this equals, now we use again our table, but we know that in table we have only probabilities for z to be less than positive numbers. So what we have, this probability that z lies in the range between minus 1.5 and 1.5 is equal to probability that z is less than 1.5 minus probability that z is less than minus 1.5. z less than 1.5 includes z less than minus 1.5, so we should subtract it to get probability for z to be in this range. And this now equals to this probability. First probability we can find from the table for normal distribution. And next one, as we remember, this is equal to 1 minus probability that z is less than 1.5. And therefore, what we got is all together this equals to 2 times probability that z is less than 1.5, or 2 times value of phi capital at 1.5 from the table for normal distribution minus 1. And this value of phi at 1.5 is, find it yourself in the table for normal distribution. Here I will give you answer 0.9332 and minus 1, and then we got 0.8664. Now let us summarize techniques which we used to solve previous 3 problems. So what we did, we transferred problem in terms of x, which has normal distribution, to the problem in terms of z, which has standard normal distribution. Then there are a few cases. First case, if eventually we want to find probability that z capital is less than z small and z small is positive, then this probability equals to value which we find in the table for normal distribution. If we want to find probability for z to be less than small value z, and z small is negative, then probability which we are looking for will be equal to 1 minus probability that z less than minus z, and since minus z now is positive, it's 1 minus phi of minus z. Third case, if we get into this kind of problem, probability, we are looking for probability for random variable z to have value more than z small, then this will be equal to 1 minus probability that z is less than z, and if z is positive, and this is found with one of first two ways, use 1 or 2. Okay, and two-sided case, we want to find probability that random variable z is more than z1, less than z2. Then this equals to probability that z capital less than z2 minus probability that z capital is less than z1. And each of these is found 1 or 2, 1 or 2. There is also another class of problems. I will show you example on the next slide. So in this problem, what is known is probability that z capital, let's say less than c, equals to something known, for example 0.95, and the problem is what is c, find the value of c. So the last type of problem is illustrated by this example. The diameter x of a steel bearing is normally distributed with mean value 3.76 centimeters and standard deviation 0.02 centimeters. Find the value of c such that 97.5% of steel bearings have diameters less than c. So what we should find here is, again, what we know. X has normal distribution with mean value 3.76 and variance 0.02 squared. We want to find probability, we want to find value of c such that probability that x is less than c is 0.975. So problem is find c. So what we do? Probability that random variable x less than c equals to probability that random variable z, which has standard normal distribution, less than c minus mu divided by sigma, and this equals to probability. Now we can put values of mu and sigma. That is less than c minus 3.76 divided by 0.02, and this should be equal to 0.975. So what we find? We find we find from the table of, and this equals to 0.975. So now we know value of phi, let's say phi of x equals to 0.975, and from here we can find that x is equal. So now we use table for normal distribution in opposite way. This is value of function phi capital, and this would be value of x, 1.96. Therefore, from here we find x equals to 1.96, and therefore c minus 3.76 divided by 0.02 equals to 1.96. And from here we find c equals to 3.76 plus 0.02 times 1.96, and this equals to 3.7992 centimeters. This value 1.96 is very important value, which is worth to remember. What does it mean? It means that probability that z, which has standard normal distribution, is less than 1.96 equals to 0.975. From here we can find that probability that z is between minus 1.96 and 1.96 is 0.95. So it is 95%. What does it mean? We have random variable z, which has standard normal distribution. And if we make a measurement or make an experiment or take one single observation, then with probability 0.95, it will be in somewhere here. It will be close to mean value plus minus 1.96. Probability for z to have a value between minus 1.96 and 1.96 is 0.95. So this 0.95, you probably remember it from the way we tested hypothesis using chi-square test. So 0.95 is given confidence level. We will talk about this more later on, but for now I can put these numbers. So probability that z by absolute value less than 1.96 is 0.95. So this is confidence level that z will be around its mean value, which is 0. With this confidence level. Then there are two other often used values. Probability, we can find probability that for z to lie in some range such that this probability equals to 99, 0.99, And this value, you can find it also. You can just exercise and try